Hello, everybody. As Sarah mentioned before, my name is Willy Alarcon, and I'm the advisor for the WaCCliM project. I will now introduce also in a more specific way on how we can mitigate greenhouse gases emissions in the water sector. And yeah, the title of the presentation is How to Decarbonize the Water Sector. I think also to clarify, most of the slides here are related from the point of view of the utility. But yeah, I mean, I think in some cases we can generalize at different levels, like end user or country or industry level. So here is a brief outline of my presentation, a small background, also what is the energy intensity and greenhouse gases emissions in the water sector. What are the sources of emissions? In this case, it's for the urban water cycle. Then we go to the section of how to scale up the mitigation actions. Then some examples, very generic in 3 countries, developing countries that are trying to implement some mitigation projects in the water sector. And then also a brief overview of climate finance, because at the end it's important also to see how we can get the resources to implement the projects. And last but not the less important, co-benefits. I think during Astrid's presentation we already have heard about impacts on health, impacts on quality of life. So it's important also to highlight that, yeah, I mean, in the water sector, and maybe most of you know that more than me, the impact of water on different SDGs is very relevant. So, okay, just jump directly to the discussion. So, what is the importance of the water sector? Mainly to provide from the, again, this from the point of view of the utility. So it's to provide water to domestic, public, and industrial users, to collect water pollutants discharged by users, to treat this wastewater, removing the pollutants, cleaning, and then being able to release in a safe manner to the environment, and also to dispose these residues in a safe fashion. At the end, I think the most important message is like, water is the single more important shared resource across all the supply chains. Then, a little bit of information about what is energy intensity and greenhouse gases emissions in the water sector. Here, I think I like to emphasize in this slide, because usually we see the water from different aspects. We see the water as a component of energy, because we need energy for pumping, for example, water. Also, we see wastewater as a component of a waste process, and also we see the disposal of some resources as a component of land use. So usually water emissions are split in different sectors. But if we put all these sectors together, then we can realize that the impact of water and greenhouse gases emission is very important. And the potential of mitigate this emission is very relevant in order to achieve all the targets that the countries have set in the Paris Agreement, and also to improve the quality of life in our countries. So, for example, in cities, it's up to 40% of the energy use, municipal energy use, is related to the water sector. Also, more or less, in general, we can count up to 10% of the total energy consumption in a country goes to the water sector. In industry, also the consumption of electricity or fossil fuels is very important. For example, in India, 6% of the total greenhouse gases emissions come from irrigation. This, at least only, and this is only energy, makes a big potential of energy savings in the water sector of around, let's say, 150 terawatt hours per year. This is a very important number that the water sector contributes in terms of energy consumption. Also, it's not here, but in terms of methane emissions, from the total amount of methane we release from human activities, or which is anthropogenic activities, 7% comes from wastewater. Can be municipal wastewater, but also industrial. So it's a big potential there. And that is the main message I want to send to you. And then, let me see, I have a small problem. Okay. Here is more or less in terms of energy. So what we can see here is that we see the emissions from water separated. So for example, in the case of energy, is 3 up to 5% going to water of the total energy consumption in the world. And then from industry is around 2%. But they are separated because water has never been considered in a holistic way. Sorry for coughing. Then it's important to see, at least in the urban water cycle, what are the sources of emissions. So for that, we have split the urban water cycle in 6 sections, which is abstraction, water treatment, then water distribution, then wastewater collection, wastewater treatment, and then disposal. And then for the first 3, so all the production of clean water, we have many emissions from electricity and fossil fuel use. This is for pumping, small treatment, pumping also for distribution. In the component of wastewater treatment, we have additionally emissions from methane and N2O that is generated in the wastewater and the sludge. And then we can see more or less the percentages here. We have 40% of energy efficiency we can do in abstraction. We can reduce also emissions by reducing losses in the water distribution up to 30%. If we use back the nutrients that are in the wastewater, we can save we can reduce up to 20% of the nutrients, and also we can recover energy from the wastewater up to 90%. This in terms of methane, and then we can use it for energy generation in any of their forms. So, from the point of view of our work in GIZ, we have defined kind of a pathway. What is the best way we can assess and identify the most adequate mitigation options? So the first things, and for that we are developing a tool. It's called the ACAM tool. That is just one tool that helps us to do this process we think in a more efficient way. And just wanted to present. So first, we do the CO2 assessment, the greenhouse gases emissions assessment. So we identify in this urban water cycle where are the main sources of emissions, that maybe also see where we have more potential to reduce them. Then the second step is to go to the technologies that can allow us to reduce these emissions. Then we go to the third step and say, okay, we have technologies, but we need to have some finance. We need to have the resources, financial resources to implement them. And then after we implement them, also we have to see how we can scale up these activities. So this is more or less the path we are thinking. I mean, we can discuss, and maybe you can have also other suggestions, but at least it's one first approach we're following. So in terms of the ACAM tool, which is the tool we're using to assess what are the emissions, we have different objectives. First is the greenhouse gases accounting, so then we can identify where the emissions are in all the cycle. Also, we have the energy intensity, so also we can identify in which sections of all the cycle energy is consumed in a more efficient or more or less efficient way. And then also what is the service level of performance. Also we can assess how the utilities are working in terms of service level. Also we have created a data interface, and then we have different levels of let's say, data demand. So we have from very simple information, like we have population, more or less energy consumption, to more detailed information when we have BOD values, we have more detailed information about each of the components on the water cycle. And then what is the motivation of this? As I mentioned, is identify the improvements, then allow us to do some analysis, and then also to monitor the progress if we implement any activity in the future. In the way of we calculate the emissions, as I mentioned before, we have 3 sources of emissions, or 3 gases out of the 6 generic gases that are defined by the Convention on Climate Change. So we have CO2, nitrous oxide, and methane. So in the part of electric consumption, we have CO2 emissions mainly, and this is related to electricity and fossil fuels consumption. And then in the part, in the component of wastewater treatment and wastewater discharge and slash discharge, we have methane that is generated in our treatment plants and also nitrous oxide. Here we enter to the examples. First, I want to show you the example from Mexico, which consists in increase the coverage from 40 to 80%, and also to install a new treatment plant, a UASB. And this activity has an impact on increasing or having a beneficiaries of around 100,000 inhabitants and reduce 2,500 tons of CO2 per year. Example is the mitigation action in Thailand, when the idea was just to increase the coverage for wastewater treatment and energy efficiency. And in this case, we are generating savings of around 400 tons of CO2 per year, and also benefiting around 100,000 people per year. For mitigation, in the case of Thailand, there is just a small distribution of all these sectors that I mentioned to you, and we can see that the major impact, because we are talking about wastewater project, is in the wastewater treatment and then the wastewater disposal and also the sludge disposal. Then, just going briefly to climate finance. I think in this section, the most important message I would like to convey to you is like, there are resources available to implement climate change projects and mitigation in the water sector. Having said so, there are resources outside that some people can access. For the people who are familiar, sometimes this process is a little bit long. And for that, we will explain in the next slide how we are thinking what is the best way to address these issues. But for funds, we have different sources of finance. We have bilateral development banks that work on all over the world, and in some of your countries, maybe you will have some offices working there. We have climate investment funds. Now we have one of the most popular is the GCF, the Green Climate Fund, that has maybe 4 or 5 years already working, and they are very active providing finance to climate change projects. We have also multilateral development banks, when we have all the banks that work by regions, like the ADB, the Inter-American Development Bank, the World Bank, or the European Investment Bank. And then also we have multilateral financial institutions. Besides this, also we have the normal financial institutions, banks, other funds that can be accessed by utilities all over the world. So saying that, I say, there's a finance outside, we can have access to this finance. The process is a little bit difficult. The important is to have good projects. So it's what we call bankable projects. So these bankable projects for us, the definition we're working with is that is any project that is able to attract financial institutions for supporting its implementation. No, and the main characteristics of these bankable projects is the impact of the project. Of course, it's different to have an impact to a small neighborhood than to a city or to the country. The project has to be financially attractive. That means it has to be sustainable in terms of revenues. Also, it has to be a robust and sound idea. And lastly, it's also important, what are the credentials of the entity who is thinking to implement the project? So what is the credit worthiness of the institution? So these are the main concepts to assess if the project is bankable or not. Then it's also important to do kind of a market assessment based on where the project is going to locate it. Is in a country, is in a specific region, is in a specific basin, or what are the boundaries, the physical boundaries of the project. No. Then the second is to define the strategy, what are the objectives. So then it's necessary to identify what is the level of climate finance in the countries, what are the resources that are being allocated in the water sector, both from private, but also from public entities going to governments. Then how much is allocated from different subsectors and actions. And then also if there is a market gap. And so what is the level of investment that is happening in the region or in the country? And then also it's important at the public level, so if it's a flexibility on redirect funds from different sectors into the water. And last is also to see what are the priority areas in the region. So is water or one of the water components a priority area for the country? Is possible to make it a priority? And then what is the structure needed to reach the objectives of the investment are required? So this is a little bit more or less what was in climate finance. And then lastly, about the co-benefits. Now I just have 5 main sectors that are directly affected by implementing projects in the water sector, not only related to climate change, but for example, it's improve energy efficiency, which is SDG number 1, if I'm not mistaken. Then of course we have SDG number 6, which is improve and cost efficient water services. Then also we have improve environmental health. Also we achieve climate targets in terms of mitigation and adaptation. And also, by implementing most of these projects, we have an impact in increasing the capacity of the local institutions. So we have an effective management for our projects. And with that, I just also would like to thank you. I'm really sorry that the presentation is very generic, but maybe now during the last minutes of discussion, we can have a little more specific discussion. Also, if you want to keep it generic, my pleasure. Thank you very much.